Hello, my name is Hồ Thị Minh Hạnh. Student ID is S4028021. Enroll in Cloud Foundation at RMIT University. Semester 1, 2026. This presentation demonstrates the completion of assignment number 2, AWS Cloud Implementation. It covers 6 tests completed inside the AWS Learner Lab, and we will begin right now. So this is my SID card. Alright, so for test A, it involves building a custom virtual private cloud from scratch. It is VPC is an isolated private network within AWS where the control for all IP addressing is allowed, and it's also subnet routing and security. The assignment requires a VPC named S4028021, following the student ID, spanning 2 availability zones with public and private subnets in each, and built manually without the VPC wizard. So here's my VPC name S4028021 with CIDR block 10 port 9.10.0.0.0/16, giving 65,536 available IP addresses. The internet gateway here is also named S4028021 IGW is attached. This is the front door of the VPC enabling internet communication. So I created 4 subnets across 2 availability zones, each using /24 CIDR blocks, providing 551 usable IP addresses, meeting the assignment requirements. So here's the subnet table. So for the route table configuration, the public route table is named public -RT route 0.0.0.0/0 through the internet gateway, enabling internet access for both public subnets. The private routes table named private RT has local routes only and no internet access and no NAT gateway. It keeps both private subnets completely isolated, which is the correct security posture for database resources. And this is the completed deployment for test A. So here's the test A preferences in the slides. Moving on to test B, it involves hosting a static cafe website on Amazon EC2 with a permanent elastic IP address. A pack HTTP server serves the HTML and CSS file on port 80. So I created a security group named web /s_sg with 2 inbound rules. HTTP on port 80 from anywhere allowing public website access, and SSH on port 22 for remote administration. So we can see the ports are already in the security group. The EC2 instance named static website runs Amazon Linux 2023, which is approved by Dr. Dwight via course announcement on a T2 micro instance type using the Voki key pair, placed in public subnet AZ1 with webs_sg attached. So I connected via EC2 constant instant connect and ran the following commands here to deploy the website. It is for updating packages, installing Apache, downloading and extracting website source files to /var/www/html and setting correct permissions. So here's the static cafe website loading successfully in the browser with the normal IP, which is the public IP. So and below is the elastic with the browser running with the elastic IP addresses. So I allocated an elastic IP from EC2 console and permanently associated it to the instance. So it is unlike a regular public IP, the elastic IP remains the same after every restart, meeting the permanent IP requirements. So here's the references for test B. Moving on to test C. So test C is involve a two-tier web application, an EC2 instance in a public subnet host, the inventory app, and an RDS MySQL instance in a private subnet which stores the data. So the web tier is publicly accessible while the data tier is isolated from the internet. Um, so here I created a security group, RDS underscore SG with a single inbound rule, which only allow MySQL on port 3306, source from webs underscore SG only, and it is not open to the internet. So this ensures only the web server can reach the database, which is the principle of least privilege. So the DB subnet group name my dash db dash subnet dash group includes both private subnets across both availability zones, which AWS requires for RDS deployments. So here's the details of the RDS instance. The instance name is inventory-db, uses MySQL engine and uh, on a running on a db.t3.micro instance class with 20 gigabytes of GP2 storage. It is public accessible. It is not the public access is set to no, and the database is reachable only from within the VPC via RDS underscore SG. The endpoint is inventory. The endpoint link is already attached at the bottom right of the slide. So for the dynamic website EC2 instance, it runs on Amazon Linux 2023 on a T2 micro with webs underscore SG attached. Critically, the lab instant profile IAM role was attached at launch. So it grants the instant permission to interact with AWS SSM parameter store, which is the inventory app that uses to retrieve database credentials securely. So if we didn't have this, the app cannot retrieve AWS credentials. And during the deployment, there was some compatibility issues with Amazon Linux 2023, which I tried to resolve. So for the first one, the MySQL package does not exist in Amazon Linux 2023. I had to replace it with MariaDB 105, which is fully MySQL compatible. And secondly, the SE Linux blocked Apache from connecting to the database. So I had to enable the HTTP underscore can underscore network underscore connect and HTTPD underscore can underscore network underscore connect underscore DB booleans. And the third one, AWS PHP SDK 3.62.3 is incompatible with PHP 8 on Amazon Linux 2023. So I had to update it to the latest SDK version. And four, SE Linux block PHP access. So it prevents credentials from saving to SSM parameter store. So I tried to save all four parameters using the AWS CLI. And finally, the same access package prevented automatic database creation. So I had to manually source the inventory SQL file through the MySQL client directly. So all five issues were found and fixed through both a research effort and the help of AI agents. So here's the completed results. We can see that the inventory application can run successful, and after entering the RDS endpoints, which I will show as the end of the video, uh, entering the endpoint database name, username, and password in the setting forms, the app connects to the private RDS instance and displays the live data from the database. Um, we can see the records here are Puerto Rico, Paris, and Detroit, and the data entry, editing, and deletion all persist correctly across page refreshes and confirming the two-tier architecture is fully functional. Here's the references for Testy. Moving on to Testy, it involves two S3 buckets from different business purposes. Amazon S3 is AWS object storage. Files are stored in buckets and accessed via URLs, scaling to unlimited capacity automatically. So here are both up below. Here are two of the buckets. The first one is S for 028.021 website archive hash versioning enable. So every file uploaded creates a new version while retaining all previous ones. So you can see multiple versions under here of the same file with unique version ID, and confirming version works correctly. The public access to it is fully blocked. The second bucket is S4028.021 social photos. It is configured for public read access via bucket policy granting S3 get object to all principals. Here is the video demonstrating the cafe photos loading successfully via the public S3 URL, confirming the policy is applied correctly. This is a reference for Testy. And Testy is a system architecture diagram visualizing all infrastructure components, including CIDRs, security group, route table, and traffic flows. We can see right here is the diagram show the completed S4028.021 infrastructure. Internet traffic flows through the Internet gateway to the VPC at 10.0.0.0/16, spanning two availability zones. So in AZ1, the public subnet as 10.0.1.0/24 contain both EC2 instances, static website, widget, elastic IP, and dynamic website poked behind WebSG. The private subnet at 10.0.2.0/24 contains the RDS inventory DB database behind RDS SG. So the dash arrow show the MySQL connection on port 3306 from the dynamic website to the RDS, entirely within the private VPC network. In AZ availability zone number 2, the public subnet at 10.0.3.0/24 is reserved for high availability, and the private subnet at 10.0.4.0/24 is part of the DB subnet group. Both below here, both S3 bucket list sits outside of VPC as managed services. This is the test F is we calculate the total cost of ownership estimated using the AWS pricing calculator. So using the AWS pricing calculator for Asia Pacific Sydney region, the monthly estimate is as follows. It will cost $22.86 for EC2 instances, 21.74 for the RDS instance, 13 cents for both buckets of S3, and Elastic IP and VPC components are not calculated at a cost, which counts up to $44.73 monthly. The actual assignment spend of approximately I think $3 is covered by the $50 credits in the AWS Academy Learner Lab credits. So here's the page for cost estimate, and this is references for test F. So that is the all. That is the. So to summarize, all 6 tests have been completed successfully inside AWS Academy Learner Lab under the student account S4028.021. Thank you for listening.